just going to walk into this train wreck real slow. It's like I used to teach the guys in the tow business. When you get to the accident, slow down. Take your time and just take it all in. Wowzers. Just breathtaking. I want you guys with me as my eye in the sky as I start this. This is okay. I have not put power to this, so we're going to plug this in. We're going to see if anything comes launching out of here. Multicolor LEDs on the front. Nothing's getting hot. I just want to put a few watts to it because I got to go to the customer now and be like, okay, this is going to be $700 or it's going to be $400 to it. You know what I mean? I get a full idea of what's happening here. So we're over here on the 1,000-watt scale. We're over here on the 1,000-watt scale, PEP. Those two transistors are turning on. Those are turning on. Those two are turning on. Oh yeah, input tune's horrendous, but we've got 8 working transistors. So it's a resto job. All right. Okay. So the remote wire for the fans is completely buggered off. All I've done is pull the zip ties off and start looking at this. This positive wire is about ready to fall off. That one's burned through. This has got like only the best AutoZone electrical tape we can stick on it. Same thing with this positive wire, it's about ready to go. This ground wire is, well, just broke off. Oh man. I can't look at this fucking remote no more. Time for you to die. Disconnect the fans. Oh, let's take this out of sight so it doesn't affect any of the innocent people that have worked on this in the past. That's our remote leads. Let's do the world a favor here. Oh man, look at that. I ain't got nothing plugged in yet today. Son of a diddly-doo. Must have been like I worked on shipping all morning and then running errands. All radio parts related. Let's let everything warm up. So, in all fairness, let's strip this down. We're going to get rid of this horrendously bad solder joint. I literally just turned the relay so it was sitting in a stock location. I hear parts breaking. Let's get rid of this guy. Kind of like debriding the field here. We're getting rid of all the necrotic flesh here. Oh, I didn't even notice this. It's got a friggin' Arco in it for the input tune. That's odd. Okay. Oh, let's pull this off. Come on, there we go. All right. First wires removed out of the system. What in the fucking hell? Okay. So, a couple of the things that concern me are this here. Focus. Thank you. It's this here. This here. All of this here. The silicone that they've got holding this board up for some reason. It's like they've put paper and squirted silicone underneath these two boards for some reason. This piece of paper goes all the way up past the keying circuit. I mean, this is just rough. Then my mind comes over and it looks at this connection. This is for this board. That whole glob of shit. Look at that beauty. Ooh, baby. This is going to be a long, hard hoe road, man. Need cutters. Burn up traces and everything. You know, So right now, as you guys are watching me take this apart, me and my little brain are sitting here going, is this worth it? Oh man, it smells like cat piss. Oh, gross. And what I mean, come on. What I mean, is it worth it? Is, God, every time I look away from what I'm working on, I see something new that's more effed up. What I mean, is it worth it? Is, I know that this board's got to come out of here eventually. Yeah, broke right off. Another great solder joint. Another good screaming example of solder joint technology there. This board's got to come off. Freaking broke off. This whole board has got to come out. And is it worth it or not to take the board out? Or do I just want to repair it as it sits? Jesus. Jeez. It's 2 down, 2 to go. Fun, isn't it? I know it isn't, and I apologize. I know I'm in the way right now. Wow, this is so bad. Oh my God. I couldn't have made that up if I wanted to. Look at this. Okay. You see this glob of solder? Underneath it is even a smaller glob of solder. So it's a glob of jizz on top of a glob of jizz. Oh man. Okay, I'm gonna get all this pulled out. I'm probably gonna end up disconnecting this board and pulling it out. I gotta find out what the deal is with this. I know what it is. It's called really bad technician work. They ripped the relay out and then they shoved a bunch of wires back in the holes for the relay. And then they were all making contact underneath the board and causing shit to short out. So instead of pulling the board up and doing their repair properly, they shoved a piece of paper underneath it and held it in place with silicone. So I got to take pictures of this. Damn. So we're going to take some rubbing alcohol and kind of try to clean this up a little bit here. Just gonna kind of knock the dirt off everything and make it so we got a little bit cleaner field to work with here. And the double side to this, the upside to this of working on this little towel, is that it is currently soaking through and it's helping clean up this backside a little bit. I mean, there is solder like crammed on the bottom of the transistors. Look at that. It's enough to cause the transistor to pop right there. Okay. Now we don't want to get too carried away with the rubbing alcohol. We want to give it a large amount of time before we go and we hook this up and run it, because the caps on these transistors are just held down with glue. And after being so hot and being reheated and pulled off and put on so many times, we can almost guarantee ourselves that the seal on the caps on the transistors is no good no more. So we know for a fact, most likely a little tiny bit of rubbing alcohol made it inside the transistor. So we're going to give it a hot second for that to do its magic. This is literally a Texas Star relay. I have a very small collection of these left. They're very expensive. Well, they're not really all that expensive, but let's see. If I get over here, I have 1, 2, 3, 4, 5, 6, 7 of those left that are legit from Texas Star. Like legit. All this relay does is it works with the RF transistor keying circuit, this thing, and it turns a 12 volt signal on and off to turn the bias on and off and drive the primary relay. But my job is made harder because of other people's laziness. And the reason that this kind of stuff has to be fixed is because of reasons like this here. You see this wire's all frayed off? I went and I looked, I don't have another one of these boards, otherwise I'd just change the board out. So instead I'm going to spend the next couple hours just repairing this board, cleaning it up, and making so it's serviceable. Unbelievable. But I've seen worse. I honestly have seen worse. Well, we went ahead and replaced the relay and got the whole keying circuit unfuddled. We rebuilt all the traces on the bottom for the relay. Little pro tip, don't use thermal compound to hold these little washers, the spacers in place. Us professionals, what we use is we'll solder the washers in place because they are solderable. So when you go to set it back down in the box, they don't slide around on you. So no, we went ahead and we rebuilt all the traces on the top side with little tiny 24 gauge wire, and then did the same thing on the bottom side, and then backfilled each one of the holes for each one of the legs of the traces. So now we're actually through soldered again, 100%. So no ugly wire mess like this anymore. So now we will, let's see, what do I need to do next? I need to wash this thing is what I need to do. Bath time is what we're going to do. We're going to clean it up so we got a good space to bolt this into. I'm actually very afraid of what's underneath all of these transistors, taking into account what I just found in here. This needs to get washed because there's dirt and goop all the way through here, and it just pains me to go and put this cleaned up, thoroughly repaired board back in here. Oh, and the other thing I did is I rebuilt this trace here. Remember, it was completely effed off. A little copper tape, a little bit of good soldering, fixed. You can't even tell it was blown off the board. So let's clean it up. Mother of God. Okay, so I finally get the other board in. I got it all washed. I took all the flybacks out because they're all different lengths, and I pulled all the 10 ohms out because they're all a different kind. This amp is a freaking nightmare. Okay. Hey, this is my job. I signed up for this. So I decided, because there was this metal tab pressed down across the top of the pill. I don't like that. So I thought, well, I'm going to pull this up and see what the deal is. Well, here's the deal. Is the metal tab is holding the transistor lid on. I've seen it all. That's it. I quit. Okay, now I've calmed down for a minute. So we just washed this whole thing with 91% rubbing alcohol. And this lid alcohol might have gotten underneath the lid and might have damaged the transistor, but we don't know. So my best option here that I have that's available to me in this situation is to solder the lid or glue the lid back on with high temp 2-part epoxy, the same thing they use when they do the transistors at the manufacturer. Hope that the lid kept the rubbing alcohol out for the most part that we used to just wash this thing with, and that the transistor's still good. If not, we're going to have to take the transistor out and replace it with a good transistor. That's my option. My other option is to take this very delicate board, which has been apart obviously many times, pull the transistor out again, or pull the transistor out and just go ahead and full up replace it. I gotta give credit. I gotta give credit where credit is due. That is an amazing effing workaround. Damn. Well, I can't really move it or touch this thing for the next couple hours. I gotta let that. It takes about an hour for that to cure right. It's going to be a gem when I'm done. That's all I'm going to say, is it's going to be a gem. Oh, I hate when I do this, gentlemen. I forgot to turn on my lapel microphone. So what I'm showing you here is the input and the output combiner, and I want you to look real close. It's not even hooked up, that 100 ohm resistor. But then the lead that comes from the combiner itself is also not even soldered in. And it's that way on both sides, if I remember correctly. It's rough. This one section's rough. Now we're going to pan over here a little bit, and we're going to go look at this protection snub diode that actually helps hold the relay in place. Now, it looks like it's soldered in, but it's not. The little small relay is what turns the bias voltage on. And we siphon off a little bit of that bias voltage, and that's what runs our main primary transmit receive relay. Now look at our diode. Oh, look at that. It's not even hooked up. It's not even hooked up. There's 45 joints of bad solder, but it's not even hooked. Look, the diode's just floating free. So it's not even doing its job. It goes on and on and on and on and on. The longer I look, the better this gets. Now, we were able to get the top of the transistor to be able to epoxy back down. Now, we use 2-part epoxy on this, high temp epoxy. Do not use phenolic glue. Phenolic glue puts off some really horrible vapors that can get up underneath the transistor on the inside and do damage. Now, what I'm talking about is how this relay board, they just went through and they cut all the wires, ding, 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 instead of unsoldering stuff. And then they went back and soldered all the joints together and then put heat shrink on them. So now what I've got to do is every single wire that has been cut, I've got to go back and replace with new Teflon wire. We're talking input transformers, talking output transformers, we're talking combiner wires, we're talking sense wires. All of that stuff has to be replaced. My key and relay has been completely repaired. I repaired all the traces, everything. It's back 100%. So now what I'm going to do is I'm going to pull all the caps. We're going to check all the caps on the input transformers. And now I'm talking about how I feel. I have a think and a suspicion that that end board is something out of another amplifier. If we look at the color of the wires on the input and the output transformers, we can clearly see their different color patterns and different thicknesses and different gauges. The other thing that gives it away is the capacitors are different. They're completely different. So what that means in the long haul is eventually I got to recap the whole board too. Now what we're talking about here is the quality of the ground wires that go between each one of the boards. See how now that one's all nice and smooth and slick? And we're going to come look at these. For some reason these have been taken off and they're like a nanometer away from shorting against the positive rail on each one of the boards. So those get to be replaced as well. Now we're going to talk about this red wire. Well, down on the corner of the board at some point or another the combiner has burned up so bad that it has burned the whole corner of the board off, which I show you right here. Now what I'm going to do, you can see that glob of solder there right below the red and the purple wire. It's literally almost touching a positive 12-volt rail. What I'm going to do is I'm going to pull all that garbage off of there when I pull the relay out, because I am going to take the relay out and I'm going to clean it and I'm going to do a bunch of stuff here, but I am going to repair that trace completely and get rid of that red wire. Just totally take it out of the circuit. But that's after I take a dental pick and pull all the silicone out from underneath the board and on the board. I don't get it. Why not just repair the trace? Why soak it in silicone and all the other weird stuff that's gone on? I don't know. I don't know. I don't know. The relay is going to come off. I'm going to clean all the contacts on the relay. That way, make sure we don't have a bad pass-through tune. I'm going to repair the combiner, repair the output combiner. And I think at this point, let's see, where do I go next here? Oh, yeah. Look at the one leg of the output transformer here. Look at this. There's like an angel's pubic hair worth of distance. So if that's in a mobile and then that's rattling around, look at that. It's literally touching the output transformer. That's shorting to 12-volt ground right there. You can see the burn mark on the side of the transformer from where that's been smacking into it, causing it to short out. It just gets better the longer I look at it. And honestly, the longer I look at it, the better it gets. So that's one more thing I got to fix. And yeah, now I'm going to talk about how the copper strap is holding down the lid and blah, blah, blah. Now, each one of the 1.8 ohm resistors all the way throughout the whole amplifier, I have to lift and verify they're within tolerance. But you can tell that at some point or another, somebody has wired this class C. So the way that the circuitry works for the bias is you have that big resistor, wire wound resistor that's ceramic embedded. It goes through an isolation choke which is that wire through a piece of ferrite, the 1.8 ohm resistor, which represents load and pulls the voltage down and the current down, and then it goes to the back of the input transformer. Well, somebody has pulled each one of those wires off, post the resistor, and soldered it directly to board ground, which takes it to class C, which makes it an AM only amplifier. And we can see it as we go down the board. Each one of them, boop, that one's been moved over, but since I had that board out, I cleaned all the slobber that's off the board. Solder wicked it, pulled all the slob off that end. All the boards are this way. All right, let's move on. I don't know if you all remember what this thing looked like when it came in here, but the relay is now mounted down. This is fixed. All of these traces down here in the corner have been completely repaired. All of these down here have been repaired and restored. All the capacitors on the flybacks or feed-throughs have all been replaced. All the 10 ohmers have been replaced. Every single 1.8 ohm resistor has been replaced. All the solder work has been completely redone. On-off switch has all been done. All the power wires coming from the back up to the front are now continuous. Transformers rewrapped. Transformers rewrapped. Splitters rewrapped. Bias circuits completely restored. Relay completely rebuilt. All new electrical system in it with adequate size wire. All the jumpers between each one of the boards that were all melted, they've all been replaced. Everything that has been burned up or damaged in here has been rebuilt to the best that I know how to do as of the filming of this video. Even dug most of the friggin' silicone that's holding everything out of here out. All of this has been restored. All Teflon wire now, no rubberized bullshit in here. So, the only thing that's got me a little concerned, honestly, is this cap. Look at that. When this decided to explode down here, it put some scorch marks on that cap, but we're going to see how it goes in testing. Let us not forget, this is the one that the lid came off on, because it was being held down by a copper bus or brass bus bar. This thing. Now, all I had to do to achieve this level of goodness was remove all of this. Oh yeah, and I replaced every electrolytic in here, by the way. Yep. All the 16 volt caps have now been replaced with 50 volt caps. So, what that means is you can volt this if you wanted to. Just saying. But I strongly, strongly suggest that you don't. Alright, well, I got a couple of little things left to do, like hook it up and run it. And then we got to go do something different with the power wire. And I got to build this guy some kind of a remote. Well, the remote's all been completely rebuilt. And the power wire for the fans has been completely restored. So that just looks so much better than what it did when it came in here. So much better. Okay. Let's run this and see what it does. So we've got 8 2290s, and by the way, this Toshiba is working. Titties. Okay, so he told me he couldn't get no more than 500 peak watts out of this, ever. And I say, okay, maybe. What we got going on here is a 1,000 watt silicon peak, 1,000 average, 5 watt silicon reverse, back from the bird, 10,000 watt dummy load. Amplifier's off. Hello, 1, 2. I'm gonna put about 28 watts of peak power into it. Hello, 1, 2. We're on 15 volts. Let's turn the amp on. Hello. There's 700 watts peak. Hello. 250 bird with 30 watts worth of drive. Here's our input tune. Hello, hello, hello. Hello, hello, hello. A little bit high, but half a watt, not a big deal. Okay, so let's change up a little bit. Now let's put like 120 watts of drive into it. He was saying he was putting like 150 in it and barely able to get 500 out of it. Which I would not do that now, you'll end up blowing the thing apart. I honestly think that the reason that your relay was all hanging up and you were having problems is because of that. This relay drives this relay, and if this stays latched, everything else is a mess. So, okay, so let's take the derail 955 and let's put it through its paces. I'll show you what we're putting into it for drive. Hello, 1, 2, about 125 watts. Hello, 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 hello. Let's come over here. Hello, 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 hello. Hello, 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 hello. Okay, so nothing on the path through tune. That's all looking good. So what that's telling us is that this relay, the RF is coming in. It's coming in through here, or coming in through here, going through this wire, going through this shorting bar, through here, and back out through this wire to this coax connector with no problems. Which means you're going to have great receive. That's how it translates out. Is great receive and no major SWR issues with the box in line. To the radio with the box off. Now let's turn the amplifier on. Hello. We'll make it 400 bird, and the peak scale is off the chart. And these 1200s, they don't really do a whole lot more than 1200 watts unless you start cranking up the volts. Of course, that's cheating. We all know that's cheating. So we're in 2x. So here, I'll point with this. Right there is 1,000 watts. Full deflection, of course, is over here. The 100 mark is full all the way. That's 2,000 watts. So divide that in half. The 50 mark, which is between the 40 and the 60, that's 1,000. 12, 14, 16, 18, and then 2,000, of course. Hello. Getting just short of 1,300 watts out of it, peak power with 120 watts worth of drive. Hello. Getting 425 bird out of it, which isn't T-bag. Let's go see if the striker's happy. This is the only thing I have not checked yet. So let me lock this in. Hello, 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 hello. Hello, hello, hello. 1 watt reflect. Going. It's staying stable here. It's not freaking out. I call this a win. It does have this little trimmer that's on here, but let's keep from adjusting that. Let's keep our little dick beaters off of that. I think it'll probably work out better for everybody all involved. So, needless to say, salvage the transistor, salvage the whole amp. Everything is working perfect. Don't have to worry about these caps, that's fine. Huh. Maybe all this time, labor, and love in figuring these things out is actually coming into play. See if our sideband delay is working. Yep. Everything checks out. I mean, nothing's getting hot. Nothing's out of balance. Everything's happy. So all I got to do now is, well, un-F the fan, the lid that's got some fans on it, and we're done. All it took was all day. Well, gentlemen, we're all done. This thing is done. Okay, so there is a fuse. It is inside. It is a 10 amp. This one doesn't do anything. And the way we've modified this amp to keep it from getting hot or melting down is we made it so that when we turn on the remote switch, the fans come on. Now I completely overhauled the fans, cleaned up all that mess on the inside, made it so it goes through a grommet and comes into the plug in the back. Now, for safety's sake, it's not necessary because it goes through the switch, but you never ever want to unplug or plug in the fan or the remote with the amplifier plugged in. Just don't do it. This fits on here like so. Now, your ganked remote wire here, which has got lots of major electrical concerns to me, has been removed. I have built you a new remote wire with a little bit more wire to it. This is made of Teflon. High resistance, high rub guard, lasts forever, anti-smash. Rubber, PVC jacketed junk. And this was soldered directly to the inside of the plug, where this is 100% removable with the actual appropriate plugs. The same thing with the fan. It's now removable. And you can plug in more fans if you want to just by accessing this jack. So, what we're saying is, this is finished, and it is breathtaking the difference that has gone on inside this amplifier. Let me unplug all of this. We'll set this just like so. And I want us to just kind of look back 30, 40 minutes ago in time. And after. Another before shot. And after. Gentlemen, this is the worst Texas Star 1200 I have ever seen. And I mean that seriously. This is bad. There's no excuse for why this got so bad other than lazy technician work, in my opinion. It is the best that I know how to make it. I'm doing this for two reasons right now. I'm doing that, one, so it doesn't back off, and two, so I know if somebody stick their dick beater in it, right? It's primarily to keep it from backing off. The problem with Arcos is they jiggle loose. They just jiggle loose if you don't paint them. So, that note, we're finished. We removed all of this garbage, completely rewired this amplifier, and now it works better than new. Gentlemen, my name is BBI, and I just want to say thanks for hanging out with me. I don't get to do any of this without any of you guys. I'm going to switch over to tube equipment now, and I'm starting to work on that skullcracker project. So I say, gents, thank you. Big shout out to Siglant, big shout out to Excess Power, big shout out to MechMan, Bird, Coaxial Dynamics. Always thank you to my Patreons for you guys' support. These guys down here in the corner, like right here. Honestly, I'm lucky to be here and do what I do. And I say thanks, guys. I'll see you. Click, click.